Okay, sorry. Yeah, again. So the shadow portion was basically showing us how the things are increasing and how it is decreasing. Okay, how the relationship is increasing or decreasing. Where did it go? Okay, sorry, it's connecting. Just give me 1 minute. Yeah. So you see here calories as the calorie is increasing here. Sorry, carbohydrate is increasing, calories is also increasing, and this increase is higher when it comes to higher carbohydrate. Now let's see the different columns again and what are the different values. So in category you see we have breakfast and there are more categories, lunch and dinner, and in the item we have different items here, and what and these are the different columns. Okay, now we'll try to make a plot that is called hexagon plot or hexaplot, hex plot. This is something similar to beehive structure, and in this basically what we are going to do is we are going to plot in the form of shades of color shades. Okay, how the cholesterol or the carbohydrates are related. You see here 0 is basically referring to the number here 16. Okay, very high number, and these are if it is completely white it is 0. Okay, so hex plot aggregates point in a space into hexagons, and then it is it gets colorized on the basis of intensity. Okay, so to use that we'll write dot plot dot hex bin. This is the command for hex plot. X axis we have carbohydrate and y axis we have cholesterol, and this is the color, whatever color you want, and this is the figure size and grid size. Okay, let's remove this as of now. Let's concentrate only this much. Then we have X label, Y label and title again, and now we can run it to get the hexagon plot. Okay, now what has happened here, I removed the grid size, so this grid is basically changing the size of my hexagon here. I'll put it back and you can see the size of the grid changes. Okay, similarly we have another chart that we use for bivariate, or sometimes we can also use it for multivariates where more than two variables are there. So we'll be seeing for more than two variables now. Okay, so stacked basically means one upon another. So the normal bar chart you see one single line here, but in stacked we have multiple columns stacked one over another. Okay, so what we are going to do is we are setting the figure size first, and then dot group by. What this function is doing, group by is basically grouping on the basis of a given column. Okay, so I'm grouping on the basis of category first. Group by which column? By category column. Okay, group by category column. Let's write it separately. Okay, df underscore mcd dot group by. Okay, and by what column? Okay, by is equals to category. Let's name it category, and let's understand how this is going to work. So okay, so what has happened here? Oh, sorry. Yeah, so it has grouped on the basis of category here. Okay, so first one is beef and pork. Actually it is not showing here properly, the names are not shown here properly. First category is beef and pork, and then we have beverages. Okay, then we have breakfast, So it is grouping on the basis of those particular columns. Okay. So first what I'm going to do is I'm going to group on the basis of category. Okay. And then I'm going to go to a column called as total fats. So I'll write it as total fats, total space fat. And now if I run it, oh sorry, I put dot here. And now if I write mean here, so it is going to categorize on the basis of group. So you see here it is group beef and pork, and then it is selecting total fat column and finding the mean of that. So by this way we will be able to make a table in which we'll have the total fat average for each category. So first is beef and pork, and the average fat in that is 24.8666. Similarly for others we have, and we have a table here. So now you know what this particular function is showing. And then I'm going to plot it dot bar color is equals to orange, and similarly dot bar. So this is basically what we are doing. We are using three different bar plots here. Okay, we are doing three different bar plots. Then x ticks is basically, I'll comment that. So we have labels here, we have y labels, and then titles. Okay, so as I was telling, this small box, okay, what this thing is, this is called as legend. Okay, so in this we are using three different bar plots. You see, we are using three different bar plots, and now since we are using three different, we have to tell what those three are. So we use legends in that case. Okay. Now if I run this, now you can see these are the category wise division grouping on the basis of categories. And here we have fat content. Okay, the yellow one is total fat, gray one is saturated fat, and the red one is trans fat. So if we want to understand what is the level of fat, different types of fat in a given category, we can go for stacked plotting. So by this we can see that the red one is quite small, then comes the saturated fat, and then comes the total fat. Okay. Similarly, in beverages, it is least. Okay, the fat is least. The second comes dessert. In dessert, we do not have any trans fat. Okay. Similarly, if we ask about trans fat, we do not have trans fat in dessert, salad, and snacks and slides. Okay. So this is how this is the reason why we use graph. This is to understand or take out your inferences out of the data. Like if you want to understand what your data is telling, sometimes just by seeing it through the numbers you will not be able to conclude what your data is trying to tell. But graph has that capability to make you understand by giving you the visual power. Okay? That is why visualization is very important. So again, I'm trying to see what are the different columns available with my MCD, df underscore MCD data frame, and what is the different columns and values available with store. Okay. Now I'm going to do another plot that is called as area plot. So now, so if I just write one, and if I try to print it, I'm going to get something, one single plot. Okay, this is customer and this is value, and this is one single plot, how the value is increasing. But if we plot two different area plots here, again we are going grouping it on the basis of customers, revenue and profit are the two different columns that we are going to plot using area plot. Okay, now if I run it, See, the bottom here is profit and this is the blue one is revenue. What is happening here? Okay, so profit is red and the revenue is blue. So definitely revenue is higher and profit is lower side, because revenue is basically revenue minus all the expenses, you will get the profit. Okay, so as the number of customers are increasing, the profit is increasing and so is the revenue. But you see here in this case, when we have 24,000 of customer, the total revenue is very high as compared to the lower side. So is it good to have these many numbers of customer when we have such a low profit or and such a high expense or revenue? Is it good at this position or this position? So we can find an optimum position where we can have the limit of number of customers to understand what is the expenditure we should be having and the profit we can generate. We can understand those things from here. Okay, then we have bivariate line chart. Line chart, you understand, like it's a simple line chart. But what is bivariate line chart? Okay, so we are going to use one line chart, and then second we have another line chart written in the same code, and now we are applying it over cholesterol and fat again. So by this way we are able to see how things are moving. So for beef and pork we have cholesterol value here and the total fat value here. For beverages we have fat is also there, cholesterol is there, but it is very low as compared to any other plot here. Okay, any other. Okay, let me do one thing. Instead of area here, let me write bar, and in this also let's write bar. Okay, so what wrong have I done? Customer revenue plot bar. Okay, there's something wrong. I'm not getting data here. Okay, there's something wrong there. Let me try it here. Bar. Sometime you just have to try again and again to understand what error you are doing. Yeah, okay, this is working fine. So this is stacked. Instead of line I have made it stacked now. So you understand the reason I was trying to change it to bar is the basic code structure remains same. Only here you see, if I write line, it's gonna become bivariate line chart. If I write bar, it is going to be bar chart. Okay, that's the only difference. Then we have pair plot, and what is pair plot basically? I am not gonna run this because this is going to take a bit of time. So the code is sns.pairplot, and from what source you are taking. Okay, and diagonal kind is equals to kd. Kd is basically is going to give us kind of distribution we have. Okay, so here we have a bell curve sort of thing. Okay, this is distribution. Now let's understand how this thing. So how calories. Okay, in this data source we are taking a subset, we are making a list. In this list we are taking the data from MACD store. We are taking just three columns, that is calorie column, total fat column, total fat percentage daily value, and saturated fat. Only these columns we are taking. Okay, let's do one thing. Let's remove this center one and let's have just three. Okay, so pair plot is basically what it is going to do is it's gonna understand the relationship between any two pair. Okay, we have three columns: calories, total fat, and saturated. So what are the different pairs I can form with calories? I can form a pair of calorie and calorie. Then I can also form a pair of calories and total fat. I can form a pair of calories and saturated fat. Okay. To understand how it is related with each other, we use pair plot. How each variable is related with other variable. So calories and calories here bottom. So you see it is a diagonal plot and I have written KDE. If I remove this KDE, it is not going to show me the distribution, how the calorie is distributed overall in the data set. Okay. If I remove that, I'll be getting just a simple bar graph here. Okay. So it is showing that it is a small bell curve, but here total fat, it is high in the starting and it is decreasing in the right side. Similarly, this saturated fat is starting, it is high, and then it is decreasing, but not so steeply as compared to total fat. Total fat, okay. It is a bit of more spread than compared to total fat. Okay, now let's understand calories versus total fat. As the calorie is increasing, you see, as the calorie is increasing, total fat is also increasing. Let's go to calories and saturated fat. Now, if the calorie is increasing, saturated fat is also increasing, but as compared to total fat, saturated fat is a little bit on the lower theta. That is, the slope value is lesser in case of total fat. It is very steep, something like this. It is going straight up to here. Let's suppose it is 45 degree, but here in this case it is less steeper. Okay, it is like when the calories of saturated fat is high, the calories are increasing at a lesser rate as compared to total fat. So there are different inferences that you can deduce from the pair plots, how it is related. Okay, then let's go for multivariate plotting. In multivariate plotting, scatter plot can also be used. Then comes group box plot and heat map plot. Then we have parallel coordinate plots and swarm plots. Okay, let's understand scatter plot, which we already have seen, but still let's see again. So scatter plot, here we are doing x as calories and y as total hue, total fat, and hue is basically on what this scatter plot is being applied. So I'm applying this scatter plot on the category section from the data that is referring to MCD, DF underscore MCD. Okay. Now you see these are the categories here. Okay, and how it is distributed, it is showing all the variables here. Okay, all the categories and how these have the relationship with calorie and total fat. Okay, then we have box plot. You might have seen this box plot or candle chart something in most of the cases where we have stock markets and all those. Okay, so we'll do one thing, we'll cover the box plot in a great depth in some other video, but just to understand here. Okay, that this is upper limit, this is the lower limit, and this is major portion where all the data points are lying, and this central line. Okay, this is the center line here. Okay, is basically telling where the like median of this data is lying. Now if you see this one, in this the pop sorry light watery blue or cyan color this is. So what is happening here is the lowest data point is here and highest it is very high, and this median is not in the middle. Okay, this median is, it is shifted much towards the lower side. Similarly here the median is shifted much towards the upper side, and similarly in this it is shifted towards the lower side, and in this to the lower side, and here there is like single line because it is having just one value. Okay, and these one single dot points, these are called as outliers. So box plot is also used when you want to see for the outliers. Outliers are basically data points which are not following the trend. And suppose in a company, okay, if we have 100 employees and their salary ranges from 2 lakhs to 10 lakh, and their CEO salary is something 80 lakhs. So it is way beyond the normal salary structure. Okay, so the salary of CEO is an outlier. It is lying outside the boundary that we are seeing here. Okay? As compared to the salary of all the employees, the salary of our CEO is outlier. So to detect whether there, okay, how is this going to affect, how is the outlier is going to affect your data. So if you find the average is basically sum of all the values divided by the number of values. If we have certain number of values, suppose let's take an example here. We have a list of 1, 3, 5 and 1. So what is here? 8, and let's make one more 5 here. So it is 5, 3, 8, 1, 9 plus 1, 10 plus 5, 15. So this becomes 15, and upon 5 we get average as 3. Okay, now in this I'm going to add one more number, 72. Okay, now earlier it was 15, now 15 plus 72 we have 7, 87, and number of 6. How many times it is, like 1, 14 point something. So what is happening, it is as the number is increasing. Okay, this is increasing, this is approx value, not exact. As the number, this 72 is added here, you see our average has shifted more towards this number, that is higher side. If we had more higher number, like suppose let's add 1008 into this instead of 72, so the mean will be shifting more towards our 1008, so it is getting biased. Okay, so if the outlier is added, it is dragging the mean towards itself. Okay, and similarly we have for median. Median is not that much affected, but mean is mostly affected in that case. So outlier treatment, when I say treatment, means how to uh, handle those data points which are outliers is a very important thing. Sometimes you completely remove it from there, or you, if like the removing any data point from a given data set is not the best option. Okay, so there are other ways, is like we can remove it with 90th percentile, or we can remove it with median or some other value, but deleting it is not a good option. But worst case scenario, if you do not have any other option, you can drop or delete these points, okay, these outliers. So detect whether a graph has, or any data set has some outlier, we use box plot. Box plot is very important plot, and it is I'm using it from Seaborn. So sns.boxplot x and y value, and then palette is basically we're using the color palette here, rainbow. Okay, so we get something like this. So what is the observation here that we can get from here? So DL is basically Delhi, okay, is usually higher than the rest of the state. Revenue versus state, right? You see, this is the maximum. So we can say the revenue at DL is higher, whereas the revenue at MH is not so clear, because we just have one single value. That is why we are having one line, but still we can say it is on higher side. Okay, and if when it comes to the data point, it is skewed. Okay, skewed, what is skewness and kurtosis, I can tell you, but I suggest please go through the Google and try to understand what is skewness and kurtosis. This is also covered in statistics part. Okay, so here we can say the data which we are seeing is skewed. The reason how we can say that, this median line is not in the center. Okay, These points are called whiskers. Okay, these up and bottom points are called whiskers. So this medium line is not in the center to these whiskers. It is either to the left or to the right. It is shifted either to the left or to the right. That is also another way to say the skewness. Okay, so that is how what we deduce, what we can find from the box plot, okay, from this particular table. Now let's see heat map. When do we use heat map? So heat map is basically used to understand how a particular column or how a particular variable is related with another variable, and to do so that we find correlation coefficient. Okay, we plot correlation coefficient, and correlation coefficient is going to be between -1 to +1. Minus side means it is negatively correlated, and plus side means positively correlated, and 0 basically refers to the neutral. Okay, so SNS dot heat map, what is the data source I'm using? DF store, and of DF store we are using correlation factor. So CORR is going to give us correlation factor. Okay, and naught is equals to true. Basically it means these values that you see in the boxes is basically the anout value true. If I make it false, I'll just get the colors here, no values. But it's better to have values to compare. Otherwise you can use it, you can understand by the colors. Okay, let's try to read. Postcode is high correlated with postcode because these both are same variable, so highly correlated. That is why we have one. Whereas postcode and longitude, this is longitude, you see, are positively highly correlated. But when we go for latitude, this is negatively correlated. So latitude, you know, is a perpendicular to longitude. That is why we are having a negative value here. Okay, similarly the revenue and profit. Let's understand revenue and profit. Where do we have profit? Here revenue is here and profit is here. You see, revenue is directly proportional to profit, means very highly correlated, 0.98. It means like revenue and profits are very like it's we can say one variable, that is profit, and another variable revenue, both are trying to say the same thing. Okay, that is why there is a very high correlation. They are very uh, relate, like if I say the relationship between them is very strong. That is why the value is 0.98. Okay, selling price and profit, let's understand that concept. Why are we doing this? We are doing this to understand how the selling price of a subject or any object is affecting the profit. Okay, so it's 0.76, and that is quite a good strong relationship. One is very strong relationship, and zero point 0.5 is average, and above zero point 0.5 is something, above zero point 0.5 is good enough. Now let's see cost price and selling price. So this is also highly related. Okay, cost price is 0.88% like times correlated with the selling price. Let's see some negative correlation here. The one is latitude and then longitude. So how latitude and longitude are correlated? So these are also negatively correlated. Okay, then we have this gross profit margin and profits. Okay, so we are talking about margins here, so that is why it is negatively highly correlated. So these are the different types of graph that you can use, and there are a few more graphs, but I think as you start working on them, you will definitely come to know more that there are more graphs, like violin plot is also there. Okay, and rose plot is there. So there are many more plots available, but I have just covered a few just to understand, make you understand. Okay, there are the different graphs, there are different ways by which you can understand what your data is trying to tell. And in the next class we'll be starting EDA, that is exploratory data analysis, and in that we'll be covering what are the, like what is that EDA, okay, why we do that, and what are the different types. All those things will be covered. Okay, what is the importance of that? So as a data analyst, I'll say or the data scientist, I'll say for them, EDA is one of the most crucial step, because before you try to tell anything about the data, you have to first understand the data. You have to explore your data. Okay, to explore that data, we have to do EDA, or exploratory data analysis. That step is called as EDA. So we'll be covering it in more detail, and this is one of the most important and the first stepping stone towards the data science. Okay, and with that, the lecture ends here. Thank you so much.